we're continuing on with inequalities, and today we're going to talk about solving one- and two-step inequalities. Now, the nice thing about this is you have the exact same goal as when you were solving equations, which really was to isolate the variable, to get the x or the y or the w all by itself. And how do you do that? Same way we did before, using inverse operations. So for example, if we have addition, to undo addition, we would use subtraction. If we had division, the inverse operation of that, of course, is multiplication. So let's take a look. The first one says to solve the inequality and then graph your solution. So again, we're going to draw our line. Now, typically when we've drawn our line before, when we had an equation, I usually draw it down through the middle of the equal sign. I think it looks a little weird to draw it through the inequality sign. So I usually do it to the side of it, but that's totally your choice. All right, so we have x minus 2 is greater than 4. So again, we're isolating the variable, so we're going to do the inverse operation, which is plus 2. We, of course, do it on both sides. The negative 2, positive 2 wipe each other out. You're left with x is greater than, and then we have 4 plus 2 is 6. So we have x is greater than 6, so we're saying x could be 7 or 8 or 9 or 10 or 1,000, right? Okay, so to graph this, remember, we're looking at our inequality right there. Whatever number we have there, that's where our circle goes. So on the 6. Now, the other thing you have to remember is it's an open circle or is it a closed circle? Well, we don't have the or equal to, so it stays as an open circle. Okay? Open circle. And again, it's saying x is bigger than 6, so we're moving to the right. All right, let's take a look at this one. X divided by 3 is less than or equal to 7. So to undo division, we use multiplication. We have a lot of room here. So times 3, if we do it to one side, you gotta do it to the other side. Remember, our 3's here would cancel each other out. We're left with x is less than or equal to 3. All right, now that we have our inequality, we're gonna graph it. I'm gonna come to the, I'm sorry, I messed up, didn't I? Let's try that again. 7 times 3 is 21. Okay, so x is less than or greater to 21. So I'm putting my circle at 21. Now is it an open circle like we had over here, or is it a closed circle? Well, we have the or equal to. If you have the or equal to, we're saying our solution can include the 21. So it is a closed circle, okay? We're including that. And again, it's less than, so we're moving to the left. Okay, let's just look at 2 more. Now you notice I didn't give you graphs on these 2, and I'm going to show you why in just a second. All right, 6x is less than 30. I'm drawing my line. Well, the 6 and the x are being multiplied because they're smushed up next to each other. And to undo multiplication, division. Divide both sides by 6. X is less than 30 divided by 6 is 5. All right, if they don't give you a graph and you need to draw one, or a number line really, you can keep this very simple. You don't need a whole lot of numbers. In fact, all the number lines that we've had on the examples, I think they've got way too many numbers. Make this simple. I know I need a 5 on my number line because that was my inequality. I'm just going to do one number in front of the 5 and one number after the 5, and that's totally sufficient. All right, my circle again goes at the 5. Open or closed? It's open because it's not an or equal to, and it's less than. All right, last one. X plus 9 is greater than or equal to 11. Draw my line. Inverse operation is subtraction. X is greater than or equal to 11 minus 9 is 2. Let's draw our number line. Again, there's my solution, right? or my inequality, so I know I need a 2. I'll do a 1 and a 3. I have a circle on the 2. Is it open or closed? Well, I have or equal to, so it is a closed circle, and x is greater, so we're going to the right. All right, just want to show you a couple examples with some two-step. It really is the exact same thing. You know the process of this by now. Draw our line. Now, x is hanging out with divided by 2 and plus 3. What do we get rid of first? Well, we always, when we're undoing an equation or an inequality, remember this is reverse PEMDAS, so we're going to get rid of the plus 3 first. We're left with x divided by 2 is greater than 6. All right, not quite done yet. How do we get x by itself? Well, right now it's being divided by 2, so we're going to multiply by 2 on both sides. Our 2's cancel each other out. X is greater than 12. Circle at 12, open or closed? It's open because we do not have the or equal to, so that means 12 is not really part of our solution. Anything bigger than 12 is, for example, 12.1 would be a solution. 16 would be solution, and anything larger. All right, actually going to skip that one. Let's come here to this one. All right, 7x minus 19 is less than 16. Draw our line, inverse operation, plus 19, plus 19. We have 7x is less than, we're adding up the 16 and the 19, and we have 35. How do we undo multiplication? We use division. If I do it to one side, gotta do it to the other. And we have x is less than 5. Okay, circle on 5 because that was my inequality. It is open because it is not equal to, and it's less than, so we're going down to the left. All right, one last one I want to show you. Again, this is a two-step. It looks a little bit different, but we have x minus 4, and that whole thing is being divided by 5, and it's greater than or equal to 2. All right, the first thing I want to get rid of, in this case you may be thinking, well, maybe we get rid of the minus 4, because that's PEMDAS backwards, right? But that x minus 4, it's an entire group, so we can't really break up that group. So we're just getting rid of the divided by 5 first. How do you get rid of dividing by 5? You multiply by 5. All right, the 5's cancel out. We're left with x minus 4 is greater than or equal to 10. Okay, this is just a two-step or a one-step problem at this point. The opposite or the inverse of minus 4 is plus 4 on both sides. X is greater than or equal to 14. Again, we don't have a graph here, so we need to create our own. Very simple number line. Here is my final inequality, right? So I know I need a 14. And I'll throw on a 13 and a 15. So I've got my circle at 14. Is it filled in? It is. It's a closed circle because we had the or equal to part. So color that in. And it says greater than, so we're heading towards 15 and up. I hope this helps. And now it's time for you guys to do some practice.